Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have, this is nice exponential equation problem. So this is 3 to the power of t minus 2 to the power of t is equals to 65, and we solve this problem for all the values of t. So here the very first thing we are going to do is, first we need to multiply and divide the exponent of both of these two terms by 2. So it will be written as 3 to the power of t, and its exponent is 2 by 2 minus. In the same pattern we write this term as 2 to the power of t, and its exponent is 2 by 2 is equals to 65. And further in the next step we move the term 1 over 2 inside the term, and it will be written as 3 to the power of 2 by t by 2 and its whole square, minus from here we move 1 over 2 inside the term, and it will becomes 2 to the power of t over 2 and its whole square is equals to 65. And now further in the next step we need more simplifications here, and now we first we convert this exponential equation into the simple algebraic form. So for this we will take here the base of this term is equals to 3 to the power of t over 2, and we take the base of this term is equals to b equals to 2 to the power of t over 2. So when we put both of these two values to the above equation, it will be written as in this form. So when you put this here, it will becomes a square minus b square equals to 65. So here you remember one thing is that in this question we have our t should must be belongs to an integer. It means that we solve this problem for only integer values of t. So you see that this is a very famous algebraic formula. You know about that a square minus b square equals to a minus b times of a plus b is equals to 65. So you see that these are the two factors which are multiplied by here. And now in the right hand side we have only one factor, so we need to find any two positive integers whose product becomes here 65. So we have some possibilities are 5 times of 13 is equals to 65, and 13 times 5 is also becomes 65. 1 times of 65 becomes 65, and 65 times of 1 is also becomes here 65. So we have these four possibilities in which we compare our left hand side, but if we make the relation between a minus b and a plus b, it will be written as a minus b is always less than or equals to a plus b. So here we choose those pair of numbers in which the first number is less than the second number. So you see here this is 5 and 13, and we know that 5 is less than 13, so we accept this case. In this case 13 is greater than 5, so we reject this case. In this case 1 is less than 65, we accept this one, and 65 is greater than 1, so we reject this one. So here we have two correct possibilities which we can choose here, but here I can just choose only one pair because we need to find the value of t, and now here from any one case we can easily get the value of t, so that we compare both of these two numbers with 5 and 13, and it will be written as a minus b is equals to 5 and a plus b is equals to 13. Okay, so we have, this is only one possibility, and from here we get we easily get the value of t. So we call this is our equation number 1, and this is our equation number 2. So we need to solve both of these two equations, and we easily get the value of a and b. So in the next step here we sum up equation number 1 and equation number 2, and in this side we subtract equation number 1 and equation number 2. So when we add equation 1 and 2, you see that this is negative b and positive b are gone, and we get a plus a becomes 2a is equals to 5 plus 13 becomes 18. And now for the values of a, we divide both of the sides by 2. This 2 and this 2 are gone, and we get here 2 times 9 becomes here 18. So here we easily get the value of a is equals to 9. And if we subtract 1 and 2, so if we subtract, we need to change the signs. So this a and a are gone, and minus b becomes minus 2b, and 5 minus 13 becomes minus 8. And now for the values of b, we divide both of the sides by -2, and this -2 and -2 are gone, and this is 2 times 4 becomes 8, and we easily get the value of b is equals to 4. So we obtain the value of b is 4, and we get the value of a is equals to 9. And now we need to move backward, and here we substitute these values of a and b into the values of a and b here. Okay, so when we back substitute these values, it will be written as in this form. So here the value of a is 3 to the power of t over 2 equals to 9, and the value of b is 2 to the power of t over 2 is equals to 4. So from here we write this 9 as 3 square, and in the left hand side we have 3 to the power of t over 2. So here you see that the bases on both of the sides are same, so we need to equate its exponents, and when we equate its exponents it will be written as t over 2 is equals to 2. So we move this 2 to the right hand side, and we easily get the value of t is equals to 4. So this is the one value of t, and in this case we have 2 to the power of t over 2 equals to, this is 4, and we write it as 2 square. So here we need to compare the exponents, and when we compare the exponents we will get here t over 2 is equals to 2. So we move this 2 to the right hand side, and in the second case we again get the value of t is equals to 4. So you see that on both of these two cases we get the only one value of t, that is equals to 4. So in the next step we need to verify that is these values of t be the solution, or is these values of t be the extraneous root. So for verification of this, we need to copy down given question statement here, and our given question statement is 3 to the power of t minus 2 to the power of t is equals to 65. And here we substitute the value of t is equals to 4 into the left hand side, and we check its behavior. And when you put it here, it will becomes 3 to the power of 4 minus 2 to the power of 4, and we check that is this equals to 65 or not. So here we need more simplifications. You very well know about that. 3 to the power of 4 becomes 81, and 2 to the power of 4 becomes 16, and we check that is this equals to 65 or not. So when we subtract 81 minus 16, we clearly get here 65 is equals to 65. This shows that both of the sides are equal. It means that the value t equals to 4 is satisfied our given question statement. And finally we have the solution set of this problem is t is equals to 4. So this is the only one integer value exists. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.